Geometry today we are learning lesson 4.4, which is a bunch of letters that's an acronym. I mean, it's not actually an acronym. I'm making it one, but I like to say all of these letters as fast as I can. So Cpctc, and I think all of you should say it just because it's fun to say Cpctc. So what does it actually mean? It means that all corresponding parts of congruent triangles are also congruent. So if we have proven a triangle congruent, then we can go ahead and say that means that a side length is congruent to the other side length, because if we've proven the triangles are congruent, then all of the parts of those triangles are also congruent. So corresponding parts of congruent triangles are congruent. So you first have to prove the triangles are congruent, and then you can say all of their parts are also congruent. So let's look at this first example problem. I'm not sure why it didn't copy, but this box should have been parallel lines. So one of the givens is that AB, side AB, is parallel to DC, and that's already marked up. They've got the little triangles here. So that's given. Angle BAC is congruent to angle DCA by alternate interior angle theorem. So let's think about that. If you have these two parallel lines and they're cut by a transversal, that makes this angle congruent to this angle because they are alternate interior angles. So they went ahead and wrote all that, but I marked it up. Okay, next we have another given. I don't know why they separated out these givens. I usually put all of them in the first statement, but that's okay. It doesn't matter really where it's at. Angle B is congruent to angle D was given. That's why it's already marked up with the two little arcs here and here. Okay, cool. And then they moved on to say now we have AC is congruent to CA by reflexive. I think this is more symmetric because it opened the letters back up. It went ACCA. To me, I mean, and I don't really care, but I think that it should be AC is congruent to AC if they're going to use reflexive. So let's just make it that. And reflexive is this line in the middle. That means it's congruent to itself. Oh, I do see why they did that, because in one triangle it would be going this direction, and in the other triangle it would be going this direction. But that's okay. If a segment is congruent to itself in any order, reflexive. All right, and then they're done. They said, okay, we went ahead and named the whole triangle congruent. Triangle ABC, A to B to C, is congruent to triangle CDA from C to D to A. So these two triangles are now congruent by reason of angle, angle, side, because they have done an angle, another angle, and the side. An angle, an angle, and another side, and the side, sorry. So normally in geometry we stop there and we say, okay, you're done. You guys have proven the triangle is congruent, so you're done. But in today's lesson with Cpctc, we're taking it a step further and we're saying, okay, so if the two triangles are congruent by angle, angle, side, that means that all the corresponding parts, angles, sides of each two triangle are also congruent. So what we were trying to prove actually is that BC is congruent to DA. So BC is congruent to DA. So BC must be congruent to DA because we've already proven the triangles are congruent, and therefore corresponding parts of congruent triangles are congruent. All right, this one was all worked out for you. Those are just kind of your examples. So let's actually try one. Here's our picture. These are the two triangles. The first one is given, so let's write down what the givens are. The givens are MN, side MN, is congruent with side MP, and then side NO is congruent with side PO. And those are already marked up, so we don't have to mark those up. Those are given, done with that. Then it says MO is congruent to MO. Side MO is congruent to side MO. So in both of them, it's the same side length. So I'm going to give it 3 little hash mark things, and the reason is reflexive. It is equal to itself in both this triangle and this triangle. All right, what would be next? So we're not trying to prove that the triangles are congruent. We're trying to prove a part of the triangles are congruent. So the next step would actually be our triangle proof. So we need to now go ahead and prove that triangle, doesn't matter which one we start with, let's go MOP, MOP. Triangle MOP is congruent to triangle MON. And the reason is because side, side, side. So we've proven side, side, side in all three. So side, side, side. So normally we'd be done here. However, we're not trying to prove the triangles are congruent this time. We're trying to prove that angle N is congruent to angle P. Angle N is congruent to angle P. And now that must be true because we've already proven the triangle is congruent. So this means that corresponding parts of congruent triangles are congruent. And if you want to write out all those words, you feel free to do so. But Cpctc is going to be my go-to. It's, again, a step further than proving the triangles. It's proving now the parts. All right, we got a couple more to try just to make sure this makes sense. So number 3 is another proof, and this one gives us no help at all. There's no question marks, no little steps. We have to do it all. So let's put statements on one side and reasons on the other, and let's just jump in. So I would say let's first do our givens. Side QK is congruent to side QA, and also we know that QB bisects angle KQA. Okay, that was all given. So let's make sure it's all marked up correctly. So these two are congruent, and this bisects these two angles, which is why those two angles are now congruent, equal to each other. Actually, we don't know that. We've marked it up, but we should actually go on the next step to writing that these two are congruent by definition of angle bisector. So here we go. Angle KQB is congruent to angle AQB. And that, again, is because it said something about bisecting. So this is by definition of an angle bisector. So by definition of an angle bisector, it made these two equal angles, equal congruent angles. All right, where can we go next? We have the side and we have an angle. And I hope that your brain is telling you to go to the reflexive side. So let's mark that up and say that QB is congruent to QB in both triangles because of reflexive. All right, and then I think we're done as far as proving the triangles because we've got a side, an included angle, and another side. So we've got side, angle, side. So let's go ahead and write out that the entire triangle KQB is now congruent to the other entire triangle AQB because of side, angle, side. And that's not what we were actually trying to prove, but now that we have proven the triangles are congruent, we can prove all corresponding parts must also be congruent. So now we can say that KB has to be congruent to side AB because of the corresponding parts in congruent triangles. Corresponding parts of congruent triangles are congruent. Cpctc. All right, last one. I'm going to encourage you guys to push pause on the video and try this last one on your own, and then fast forward this video back and just make sure you got all the steps correct. If you're not quite ready to try it, I will definitely work it out right now, but I would say you're probably ready to try. All right, I'm going to start by definitely doing the givens first. So side ON bisects angle JOH, and then I'm also going to go ahead and say that angle J is congruent to angle H. Those are all given. Okay, let's make sure they're marked up. They're not marked up. The J is congruent to H is marked up, but ON bisecting JOH is not marked up. So that means that these two angles are congruent to each other by definition of bisector, of an angle bisector. So we're going to say angle JON is congruent to angle HON by definition of angle bisectors, of an angle bisector. All right, the next one would definitely be our reflexive segment here. So ON is congruent to itself because it's reflexive in both triangles. All right, and then I think we're done because we have an angle and a side. The side is not between, so it's not angle, side, angle. It's angle, angle, side. So we can go ahead now and say that the entire triangle JON, and again, the order doesn't matter of how you put this as long as it is consistent with the order that you're putting the second one, to HON, and the triangles are congruent by way of angle, angle, side. And now that we've proven the entire triangles are congruent, that means all the parts are also congruent, including side JN being congruent to side HN, and that would be because of Cpctc.